This video will go over graphing techniques and graphing of quadratic equations. One of the first things I want to mention is that we can have quadratic equations into three different forms. The first one being standard form, the second one being an intercept form, and the third one being what we can call a graphing form or the vertex form. So I like this form because it relies on what we already know about parent functions and their transformations. So this particular part of this handout will actually remind you of our transformations. So we've discussed all of these in the previous unit, but we will actually be using them only for quadratic equations in this unit. So let's take a look at example number 1. Our job is to graph the equation of y is equal to x squared minus 4x minus 2. Because this is in standard form, we can quickly see that there is a point when x is equal to 0 and y is equal to negative 2. This is our y-intercept. Again, all I did was substitute 0 for x, and we can quickly see that our y-intercept is 0, negative 2. We can try factoring this so that we can find our x-intercepts. However, we're looking for factors that multiply to negative 2 but somehow subtract to 4. So we're not going to be able to factor this particular equation. So the next thing we're going to consider is how to put this into vertex form. So again, we're going to use y is equal to, and in parentheses I'm going to use x squared minus 4x to show that I'm separating it from my constant of negative 2. And now I can use completing the square to complete this part. When I do that, half of negative 4 is negative 2, and square that is 4. Now notice I can just simply get rid of my parentheses and I end up with my x squared minus 4x, but I still have a plus 4. So to undo that plus 4, I'm going to subtract 4. Now I'm going to have y is equal to x minus 2 squared minus 6. This will tell me that the vertex is located at 2, negative 6. This also tells me that the axis of symmetry is at x is equal to 2. So let's graph the information we have, and then we'll use what we know about transformations to complete our graph. So we're going to graph 0, negative 2. That's our y-intercept. We're going to graph the vertex, which is 2, negative 6. And the only other thing that we know is that our axis of symmetry is at x is equal to 2. As we continue our graph, what we can see is that the axis of symmetry, remember, is actually cutting up our parabola into two parts that are reflected about the axis of symmetry, meaning that there is another point on the other side of my axis of symmetry the same distance that this point is. So notice we have found 3 points even though we only had 2. We only had our y-intercept and our vertex, but using the axis of symmetry gave me another point. Now let's use our knowledge of transformations and realize that only horizontal shifts and vertical shifts have occurred, meaning that I can still use my original values of my parent function, like 0, 0, 1, 1, 2, 4, 3, 9. So I'm going to use that from here. Notice this is my new origin, if you will, after we did our transformation. So we went go over 1 and up 1, go over 2 and up 4, 1, 2, 3, 4. We already have that point. And then go over 3, 1, 2, 3, and then up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using our axis of symmetry, we see that there's another one over here. And this is 3 units that way, so 3 units this way will give me another point. And I can see if I can graph some more. I can do a 4. 4 squared is 16. If I add 16 to negative 6, that's going to give me a positive 10. So I suspect that this other point is going to be up here. Notice it's 4 away from my axis of symmetry. So 4 away from my axis of symmetry. And we can see that this is what our parabola is going to look like. Now it also asks us for our domain and range. So remember, for our parent function, we know that our domain is going to be from negative infinity to positive infinity. And shifting our graph left and right will not change our domain. Our range from our parent function was actually from 0 to infinity. But we have changed it up and down, so therefore our range will change. In fact, we're going to start at some other number. In fact, we can see that because it went down 6, we're going to start at -6 and go all the way up to infinity. We can also look at increasing and decreasing intervals. Just to give you some refresher on that, we can see our y values are decreasing on the left side of my axis of symmetry. So I can write down decreasing from negative infinity until we get to my axis of symmetry, which is 2. And then we can see that it's increasing from the axis of symmetry all the way to positive infinity.